This is our last chapter on organic functional groups. After this, we're just going to look at biomolecules. So the last functional group is going to be the amines, and we've already seen amines and we've seen how to form them in places. Now we're just going to look at a chapter where all we do is look at amines and how they're made and what kind of reactions they undergo. So a lot of this chapter will be review, and there will be a few new reactions thrown in. We've already seen that we can have primary, secondary, and tertiary amines. We can have aliphatic amines. We can have aromatic amines. We can even have amines in rings. We've seen these when looking at aromatic compounds. For instance, we found that pyrrole here was aromatic. This is aliphatic. It's called pyrrolidine. Here's pyridine. That's been a reagent that we've used a lot of times when we want a non-nucleophilic base. This is imidazole, and that's a common heterocyclic amine. And here's pyrimidine, another common heterocyclic amine. The aromatic amines are important in biochemistry because we'll see them in many molecules, particularly though we see the purines and pyrimidines repeatedly in biochemistry, because purines and pyrimidines are the bases that form the nucleotides in DNA and in RNA. So here's purine. It is a two-ringed compound, and pyrimidine a single ring compound. Notice that you have 4 different nitrogens here. This one right now here, the nitrogens there are in the aromatic ring, so this is a non-basic nitrogen. Here, this nitrogen has an sp2 non-bonding pair. This one has an sp2 non-bonding pair, and this one has an sp2 non-bonding pair. So this is basic, and that's why they call them bases. In pyrimidine, both nitrogens have their non-bonding pairs in sp2 orbitals. The number of alkyl groups on the nitrogen does change the classification of the amine. Primary amines have just one alkyl group on the nitrogen. Secondary amines have 2 alkyl groups on the nitrogen, and tertiary amines have 3 alkyl groups on the nitrogen. See right here, this is primary. You see the 2 hydrogens on it. Secondary, only 1 hydrogen, and tertiary has no hydrogens on it. Amines are bases. There's a non-bonding pair on the nitrogen, and it will pick a proton off acids and make an ammonium compound. So an amine with water will react and make the ammonium hydroxide. Notice this is an equilibrium because this is a weak base, and the equilibrium is really favored over here. The basicity depends on the non-bonding pair and how available it is. If you have electrons being pushed into the non-bonding pair, it becomes more basic. So alkyl groups on a nitrogen make the nitrogen more basic because they're electron donating. If you have electron withdrawing things on the nitrogen, well then it's less basic. Anytime you have a pi system that is conjugated with the non-bonding pair of the amine, you're going to have that non-bonding pair in a resonance structure with the pi system, and so it's less available for protonation, so it's less basic. That is why amides, which have their non-bonding pair highly tied up in the pi system, are non-basic. But even amines that are adjacent to an alkene or adjacent to an aromatic system are less basic because the non-bonding pair participates in resonance with those pi systems. Amides, remember, are non-basic. Even though they can hydrogen bond with water and with each other, the hydrogen bonding with water makes them more water soluble than the average organic compound, and the hydrogen bonding with themselves gives a high boiling point. But remember, amides are non-basic. The nomenclature of the amines starts with naming the alkane. Find the longest chain that has the amine group, unless there is another functional group that has higher priority. What you do is you name the alkane, and then you take the E off and add amine on the end. And so let's say an amine that is on the end of a 4-carbon chain, we would name that butane, and then we would call it butamine. But we would need to locate the amine, so then we say 1-butene. If it was on the number 2 carbon, of course, 2-butamine. Any substituents after that need to be named. If there are more alkyl groups that are on the nitrogen, then you just give those an N designation. So, for instance, a butyl group on a nitrogen and a methyl group on the nitrogen, the longest chain is the butyl, so we call that butanamine. And then we call the methyl that is on the nitrogen just a methyl group, and we say N-methyl butanamine. Here's an example. Let's name the longest chain. Right there, that's 5 carbons. So that's going to be pentanamine. It's on the number 2 carbon, so we put a 2 in front. Now, what are the substituents? The substituents are an ethyl and a chloro. C comes before E, so you would say 1, 2, 3, 4 chloro. And then you would say N-ethyl. And so the 4 chloro should come first, because chloro comes before ethyl. My bad there. Okay, go ahead and draw N-methyl 2-ethyl cyclohexanamine. Okay, the first thing that we do on this is we draw the cyclohexanamine, which gives us cyclohexane and an amine attached. There's a methyl on there, so it's N-methyl. And then on the number 2 carbon, the nitrogen must be the number 1. You have the ethyl group. So what is the name of this amine? Well, the first thing we have to do is find the longest chain. 1, 2, 3, 4. So that's going to be 1-butanamine. 1 because the nitrogen is on the number 1 carbon. Then we're going to see we have 2 different methyl groups. There's a methyl on the nitrogen and a methyl on the number 3 carbon. So it's going to be N3-dimethyl. And then on the nitrogen, we also have an ethyl, so we have an N-ethyl. So N-ethyl, N3-dimethyl, 1-butanamine. If the amine functional group is lower priority, you're not going to name that, or you're going to make it a subordinate functional group. And to make it the subordinate functional group, we call it an amino. So this is benzaldehyde. So what we do is we say 3-amino or meta-amino benzaldehyde. There's an E missing here. Okay, so go ahead and name this compound. Well, if I look at this, we can see there is an amide functional group. I count the carbons, 1, 2, 3, 4. So it's butanamide. And then there's on the number 2 carbon an amino. So it is 2-amino butanamide. These are some common amines that I want you to know, both aniline and pyridine. Be sure to know the structures of